So we were doing kinetics, and this is a very small unit, but very important. It's going to dominate in your exam. And you can see here, I think I already started this unit, and I told you about the rates of the reaction. So what is the rate? Change in concentration per unit time. What are the units of rate? Molarity per second. So all these things we did in the last class. And then we did some questions, how to relate the rate of appearances and disappearances of the products and reactants with each other. And I think we did these two questions. Am I right? Ariba, Aditi? All these things we did, right? We did these two questions, Anil? Anil, we did these two questions in the last class? No? Oh, okay. We did this part, right? How to relate the rate of appearances and disappearances. Okay. So if there is a chemical equation, the coefficients here, they indicates that how these rates are related to each other. This is the rate of disappearance of A, and this is the rate of appearance of B. Appearance, this one. Exclude this two. But they will become equal to each other if I divide this rate of appearance by 2, because this is 2 times more than that of A. If 1 mole of A disappears, how many moles of B are disappearing? 2. So that's why it has to be divided by 2. So that's how we relate the rate of appearances and disappearances. Disappearances with the negative sign, there's a negative here. Appearances with the positive sign, their concentrations are increasing. From the balanced equation, you can divide A by 1, B by 2, C by 3 like this, right? Okay, now Anil is saying we did question 1. So now we are going to do question 2. Question 1 we did last time. I remember that we did it. Now let's see question 2. In the question 2, what's the relationship between the rate of production of ammonia and the rate of consumption of hydrogen? Equation is here. You can see the equation. This equation. So rate of consumption means disappearance. So minus for N2, delta means change. N2 in square bracket means change in concentration of N2 gas. Negative means the decrease divided by delta T. It is the rate of consumption of N2. Consumption because it's the reactant is equal to, yes, upon H2. What is it? It's also the reactant. It is also being consumed, disappearing. So put a negative. Negative means disappearing delta H2 over delta T. But this coefficient, these are not equal. It should be divided by 3. Why? Because the rate of consumption of H2 is 3 times more than that of N2. If you want to put them equal, you have to divide it by 3, which is equal to, now this is the one which is formed, produced. This is the one for which they are talking about the rate of production. Production means plus appearing, it is appearing. Its concentration is increasing per unit time, but it should be divided by 2, because if N2 is disappearing, 1 is disappearing, 2 is appearing. So to put them equal to each other, divided by 2. So that's the relationship. That's the question. Can you answer my question, children? If the rate of disappearance of N2, N2 is 6 molar per second. This is rate, unit of rate. What is the rate of disappearance of H2? Answer it. This value is given 6. And they are asking this. They are asking this with negative sign, of course. This one. So, no, there is no minus. Minus is here. This minus is here. This value is not minus 6. It is 6. So you can say 1 over 3 is 6 molar per second. Answer is minus delta H2. So with the number, don't put minus, Anil. Numbers, they don't have minus. Concentrations are never negative. So answer is 18 molar per second. What about rest of you? Only Anil is answering. What about rest of you children? Can you answer this now? Ammonia, this one. The rate of formation of ammonia. Yes. NH3 over delta T. It will be, you take this 2 over here. What is the value of this? 6 molar per second. So yes, Aditi, good. Molar per second, yes. So it is 12 molar per second. So rate of disappearance of N2 is given and equation is given. You can relate, you can put the relationship like this. My aim is to make you understand that first, these numbers will never hold any negative sign with them. There's no negative on these numbers because these are change in concentration over time, concentration. So don't put any negative there. Negative is here, here. This negative indicates this is disappearing, 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 appearing, forming. So please don't put any negative here. Second, the rate of disappearance or appearance for anything is this, like the rate of disappearance is this. I'm just highlighting it. This one, this complete, this complete. This complete expression is called as rate of disappearance of N2. This complete expression, this one, exclude 3, is rate of disappearance of H2, this one. And this complete expression is rate of appearance of NH3. So this is one set of questions for your AP exam. They will give you the equation. They will give you some values. From there, you are going to work out rates. Some more questions will come. Now, 2 important definitions will come about rate. Look at this data table. Look at the equation. What's the rate in terms of BR2? Minus delta BR2 over delta T is the rate. Agreed? That's the rate. Fun, come back soon. Is the rate, right? Now look at this concentration versus time. Is the change in concentration, if you see carefully and draw a graph of change in concentration versus time, this graph, concentration versus time, you're not getting a straight line. Aditi, we are not getting a straight line, right? What does it mean? It means the change in concentration is not constant. You can see the change in concentration as on this side as delta y. This is y-axis. This is x-axis. And change in time as delta x. What is this delta y over delta x called as? For a straight line, for a line, what is it called as? Slope. Is this slope constant? No, it's changing continuously. When is the slope maximum? When the concentrations are highest, see? This slope is high. This is the slope. This is the slope. So what is happening to the slope? If I make a line like this, understand the nature of the lines. This means the decrease here is very high. In less time, time is less. Time is here, right? In less time, there is a sudden drop, big drop in less time. And then finally, the drop is very, very small and line is nearly becoming constant like this. It means hardly any drop. Understand the nature of the slopes, right? So here, initially, the drop in the concentration is high. This drop is high. And finally, the drop is very less. So what I'm trying to tell you that is not a constant rate. Rate is continuously changing. You can see that. These are slopes. Rate is continuously changing. If rate is continuously changing, then how to express the rate of a reaction? Then we have two terms. One is average rate of the reaction. Average rate means that you just see the total change in concentration from time 0 to 400. This is final, this is initial. Plug in here final, initial, divided by total time taken. That is average rate. You can calculate average rate between any two time intervals. Like if I say calculate average from 0 to 200. Now this is your final, this is your initial divided by 200. There is a negative here. Why? Because this answer will come out to be negative. When you plug in the values, this is low, this is high, it will be negative. So negative and negative will become positive and you'll get the rate positive values. I told you that the numbers will be positive. Molar per second is positive answer, whether it is decreasing or increasing. We are good? Children, what is the meaning of average rate? The total change in concentration, final minus initial divided by total time. That is average. And that rate of the reaction is continuously changing. So that's why we had to work with the average rate. Units, molar per second. Yes. Now there is another term, instantaneous rate. Instantaneous means at a particular instant. Like you make the concentration versus time graph. This is the data. This is concentration. This is time. Make concentration versus time graph, right? And like for example, if you want to know the rate at 100 seconds, so you draw a perpendicular like this, get a point here. On this point, make a tangent. No one is going to ask you how to make tangent or make a tangent. These questions will not be there, but you should know the meaning of instantaneous. Make a tangent. Tangent is a straight line. You know the meaning of tangent, all of you? Tangent. What's a tangent? It's going to touch from one point, right? Afan, you know the meaning of tangent? Okay, good. Now it's a straight line. What's the slope of this straight line? Delta y over delta x. Can I calculate delta y over delta x? Yes. You take any 2 points. Straight line, they have constant slope. Remember that. So you take any 2 points and drop a perpendicular here and a perpendicular here. What is this, Naisha? This is delta y. Drop a perpendicular here. Drop a perpendicular here. What is this? Delta x. Yeah. Rise and run. Yes. rise and run. You rise, how much you rise and how much you can run in this direction. That's the slope, right? So delta y over delta x is the slope of the line. So these things I'm spending time because I know that they will come in big. After few slides, you'll be working with the graphs. Okay, so that's the meaning of your instantaneous and average rate of the reaction. You can see instantaneous is changing. Is it increasing, decreasing? So here it is a table here. Check. All these are instantaneous rate of the reaction, all of them. So as the time is increasing, time is going up, time is increasing, 0 to 400. What is happening to the concentration of Br2? Check the data table. What is happening? Decreasing. What is happening to the rate? Check the data table. What is happening to the rate? Rate. Check -5. Check these values. All of them are -5. Check these values. Only Anil is doing analysis with me. Aditi, Liza, you're not doing anything? Is decreasing. These are very simple question. I know that you feel like why should I answer? But more you interact here, more you learn. So what does it mean? Can I say rate is directly proportional to the concentration of Br2? Can I say that, children? And this is called as rate law. This is the rate law. You make a graph of rate here versus Br2. You get a straight line. Straight line. And what is the slope of this straight line? Slope is rate divided by Br2. Concentration Br2, right? So this is the slope. And that slope is called as rate constant. Means you remove this proportional, the way we were doing in ideal gas laws. You remove the proportional, rate equals to K times concentration of Br2, right? This one. Is it okay? Rate equals to K times concentration of Br2. And this is your K, important new term, small k, but generally we write it like this only, but it's small letter. And it is called as rate constant. Rate constant, which is the slope of this line. So is this rate constant changing? No, hardly any change. So that's the rate law. So now the next one type of question we have done, that rates are given or the concentrations are given, time is given, get the rate. Now this is another form of the rate. That rate is equal to K times concentration of Br2. What was the earlier form? What was the earlier form? Minus delta Br2 over delta T. This is also rate. Now I'm saying rate equals to K times concentration of Br2. That's the rate law. This is the definition of rate. Average rates, you can say. But this is the rate law. Okay. For every equation, they will give you some graph and you have to understand the meaning of the graph. We are good? Units. Rate constants will have some units. Like here, you are saying rate is equal to K times concentration of Br2. What is K? Rearrange. Rate over concentration of Br2. What's the unit of rate? Units of rate. Molar per second. What's the unit of concentration? Molar. Molar cancelled. It is per second. Right, Lisa? See, the rate constant has this unit, but rate constant will show you different units in different order. So it will come in big. So let's move out of this slide. This slide is just telling you the meaning of the rate law. Okay, now let's do this question. Read this question, please. Data is given, experimental data. Calculate the average rate of decomposition of H2O2. Means minus delta H2O2 minus because it's undergoing a decrease. It's the reactant. It's decreasing over delta T. Between this time to this average rate. So what is it? Minus, keep this minus, this one, 0.500 minus 1.00 divided by this minus this, right? Total time. Is it okay? And units will be molar per second. So what's the answer? Answer will be positive. See here. That's why we put a minus here. Answer is 0.5 divided by 2.16 times 10 raised to power 4 molar per second. You can solve it. This A part is done. Up to here, it is done. The average rate of decomposition. This is the rate of decomposition of H2O2. How much is this, children? Any one of you? Use your calculator, Afan. Give me the answer. What's the answer? Aditi, what is the answer? How many sig figs? Sig fig, we are going to take 3. So answer is 2.31. 2.31 times 10 raised to power minus 5 molar per second. Why you people are not calculating it? Anil, you didn't do any calculation or you did it? Yeah, okay. So put it in scientific notation. Afan, you are not doing any calculations? Aditi, Afan, Naisha. Naisha, at least do the calculation. Make yourself expert in how to plug in the values in the calculator. Ariba, no answers? Okay. Now this is the answer of the first part. Average rate of decomposition of H2O2. Now use this rate to calculate the average rate of formation of O2. O2 is here. So the rate of formation of O2 means plus delta O2 over delta T. What it will be? Is it going to be the same? Are they same? No. It should be this number should be half of this, right? Because the rate of formation of O2 is only if 2 moles disappears, you are getting 1 mole, so they are half. So just divide it by 2. Divide this number by 2 and that is the answer for the second part. Is it okay? Now they are saying what are these rays for the time period from here to here? So minus delta H2O2 delta T is, final is this, initial is this, keep negative. So 0.250 minus 0.500 divided by delta T. How much is delta T? 4.32 10 raised to power 4 minus 2.16 10 raised to power 4. Solve it. Units will be molar per second. So how much you are getting for this one? The above number is 0.25. Okay, Anil is giving me this answer. Scientific notation, Anil. 1.16 times 10 raised to power minus 5. Is this the right answer, children? After plugging in the calculator. Okay. Now get the delta O2, the rate of production of the oxygen gas. Get this. What is the rate of formation of O2, Aditi? Rate of formation of O2 will be half of this. That is 0.508 times 10 raised to minus 5 molar per second, right? Which you can simplify in scientific notation like this, molar per second, right? Yes, Naisha, very good. Okay, so this is another type of question, but these are the questions which are based on calculation of the average rate of the reactions. So we have done one category of this chapter, this unit, kinetics, meaning of the rates. That rate is decrease in concentration of the reactant, increase in concentration of the product, and how are they related to each other? What's the meaning of average rate, and what's the meaning of your instantaneous rate? Now I'm coming on the next part. The next part is rate law. You're not answering anything and you're not asking questions. These are very simple. I don't have another question right now. Aditi, give me the messages directly, okay? In general, not direct message. Because if I start talking about what you are writing here, other children are not understanding. So Aditi has asked a question. She's saying that give another example of this time. So I was just asking that you should keep asking questions, children. Okay? So don't be very quiet during the session. If something is not clear, ask there and then only, because you'll be equally confused with the other question also. So I'm going to show you another question. These are simplest questions. They will come again in detail. There are many questions. So they will come in between. They will keep coming. See, here also there is no other question, but it's okay. We can make one. Check this one. No, data tables are not there. This is the question which I picked up from here. Okay, let's see. This one. So let's do it. I'm going to explain you this question. Okay. So don't read the question because question is something else and I'm just giving you how to calculate the average rate of the reaction. Let's say if I say calculate the average rate of the reaction between these two values, then average rate of disappearance of this, then it is minus Now this time we are working with pressures. Pressures are also a form of concentration. Delta P over delta T. What is that? Pressure of C2H5OH. So keep minus here. P final minus P initial. That's the definition of average rate. Delta T is T final minus T initial. This is your initial 0. This is your final. Now you plug in the values. What is final? 237. Initial 250. Delta T 100 minus 0 is 100. That's the answer. Units. What are the units this time, children? And you will see your answer will be positive. What are the units? No, I'm asking you to calculate in this. That's the question. Units are torr per second because pressure is in torr. Right, Aditi? Is it clear? Aditi, please respond. So these are very simple questions. Like if I say calculate between these two, now this is final, this is initial. Use this equation. Now if the rate of disappearance is of this is this value, what is the rate of appearance of H2? Naisha, no direct message, please. Please, children, don't give me any direct messages except that when you have to use your washroom or you are out of your chair for a few seconds. Otherwise, no direct messages. Because direct messages will confuse the other students because I cannot talk about these direct messages. Yeah, we are going to understand that. Factors affecting the rate of the reaction. Naisha is asking, is there any trend about the rate of the reaction? Yeah, that is what you are going to learn in this, Naisha. Big topic. So here the rate of appearance of H2 and this C2H5OH will be same. Rate of appearance of this compound and this will be same because they are 1:1:1. Yes, good. So coming back on the most important topic now. Which one we were doing? This one? Yeah, the rate law. Yes, Naisha? This is Naisha? You know collision theory, Naisha? Okay. Attention to the topic which we are doing. These are topics, definitely I'm going to cover it. So we should not waste time now on what are other topics. Let's pay attention to this topic. Work with this topic, the rate law, collision theory, everything I will do. So what is the rate law? By definition, rate law is always in terms of the concentration of the reactant. Like this is the reaction. Now rate law says that rate is equal to K, what is K? Rate constant times concentration of A, this A, the reactant, raised to power some coefficient X, and concentration of B raised to power some coefficient Y. Every time when there is a question on rate law, this is the first thing which you have to do. You have to assume the rate law as rate equal to K, the rate constant, times concentration of the reactants raised to power X and Y. This is X, this is Y, this is not A and B. So X and Y has nothing doing with these coefficients. They are not the coefficients of the balanced equation. Now, what are these X and Y? X and Y are called as order of the reaction. order of the reaction, right? Okay, now read the definition. Is the relationship of the rate of a reaction, this rate, with the rate constant, this K, and the concentration of the reactants raised to some powers. These some powers are called as order. Now, many children, they stay very confused with the order. So all of you try to understand this meaning of the order. It's not a difficult thing. Okay, Naisha, I'm not going to answer these questions. You have to stay what you are learning. You are asking ahead. Is this Naisha or somebody else sitting there? So this question is not related to what we are doing here, okay? So first, do you know the meaning of order, Naisha? What is order? So first, let me explain you order. Ask questions what I'm teaching you right now. Okay? You are asking questions how it is going to influence the rate of reaction. Influence of the rate of reaction, I'm going to teach you after covering one more topic. And that topic is integrated rate laws. After that, I'll discuss factors affecting the rate of the reaction. And at that time, I'll do the collision theory, right? So please ask question related to this. Pay attention to the meaning of the order. What is the order of the reaction? I'm ready to answer every question, children. Keep asking question. I'm encouraging you for asking questions. But my request is what I'm teaching, ask questions from there. Okay. If you don't know the meaning of the order, then pay attention. Learn the meaning of the order. What is it? I'm giving you concentration of A as 2.0 molar. Concentration of B as 2.0 molar. In experiment 1, I'm doing experiments. Experiment 1, concentration of A is 2.0, concentration of B is 2.0, and the rate is 2.0 molar per second. This is experiment 1. These are called as initial rate. Actually, they are just calculated by taking the initial changes. They are actually the average rate, but I have checked the change in concentration per unit time, starting from 0 time. This is the rate. I did the second experiment. In second experiment, I changed the concentration of A to 4 molar. But I didn't change the concentration of B. I kept it as 2.0 molar. And I found the rate has increased to 4. Now, when I doubled the concentration of A, what happened to the rate? Doubled. See? But is this B playing any role here right now? No, because it is constant, it's same. So this doubling of the rate is due to doubling of the concentration of A. So this is called as first order. First order means x equals to 1. This x is 1. Order is 1. You double A, rate doubles. You make A 4 times, rate has become 4 times. You make A 3 times, rate will become 3 times. Keep asking question from this part, okay? It's very important what we are learning. Now I perform third experiment. This time I'm not changing A, I'm keeping it constant. A, same. But I'm going to double B. And I found this rate. Compare with this. This rate I found has become 8. Now just ignore this experiment 2. Check experiment 1 and 3. In 1 and 3, is this A changing? Is this A changing? No. Is this B changing? How many times this B is changing? 2 times, doubled. But how many times the rate has increased? 4 times. When I double the concentration, when I double this value, my rate has increased 4 times. It means Y is 2, X is 1. So rate is equal to K times concentration of A times concentration of B raised to power 2. That's the rate law. Now, what's the meaning of the order? Are you getting the meaning of the order? Means whatever number of times you will change the concentration of A, if it is first order, rate will also increase by that much number of times. But if it is second order, it will become, if you double the concentration, it will become 4 times. So order means how many times the rate is affected by changing the concentration of the reactant. You know that rate depends on the concentration, right? Higher concentration, higher rates. So how these rates are changing with the change in concentration of A and B, it depends on the order. That's the meaning of the order. So in many questions, you will be given with this experimental data, and you'll be calculating the order and you'll be writing the rate law. Any question here, children? So what is rate law? Rate law is in terms of the reactant A and B raised to power some coefficients X and Y. So every time reaction will be there. So first we have to assume the rate law like this, the way it is written here. This one. I'll explain you that. So is up to here, Anil, everything clear? So I gave you one example without much explanation. I said if you double the concentration, rate is getting doubled. So it means order is 1. But if you double the concentration, rate has increased 4 times, then it is second order. Anil is asking question from there. What do you mean by this factor, that factor? So I'm going to show you nearly 5 to 10 questions based on what Anil is asking. Because you will learn better with those questions. So we are going to do plenty of such questions. So let's start with first question. You can see this table. You can see the reaction. Now, please all of you follow me. First, you assume the rate law. What is the rate law for this reaction? Rate law. Every time when reaction is given, first step is write down rate law. Rate equal to, yes, K, the rate constant, concentration of F2 raised to power X. We don't know order here. We have to calculate, right? Concentration of ClO2 raised to power Y. That's the rate law. This is the assumed rate law. Is it okay? We are good with this? Okay. Now, student is performing experiment. This is experiment 1, 2, 3. This is rate 1, rate 2, rate 3. So I'm going to show you mathematically how to determine this X and Y. Pick up experiment 1. And rate 1 is K times, what's the concentration of F2? 0.10 raised to power X. ClO2 0.010 raised to power Y from here. This is rate 1. Now pick up rate 2. Rate 2 is K times 0.10 raised to power X 0.040 raised to power Y. Am I right? No problem? Now you do one thing. Which number is greater? This. Take the ratio of rate 2 over rate 1. I want to keep this bigger number in the numerator. So 4.8 times 10 raised to power minus 3 divided by 1.2 times 10 raised to power minus 3, right? This number divided by this. Take the ratio here also. So K 0.10 raised to power X 0.040 raised to power Y divided by K 0.10 raised to power X 0.010 raised to power Y. Do mathematics to get the value of X or Y. What is this? 4. K cancel. K is the rate constant. Remember, it has a constant value. It can be changed only by changing temperature. K is cancelled. Is this cancelled? Yes. So there is no X. We are left with Y. Can I write it like 4 over 1 raised to power Y? So what is Y? Y is 1. So you know the order with respect to ClO2, 1. 1 means you double the concentration, rate doubles. You make the concentration 4 times, like here, you are making it 4 times. 4 times. How many times the rate has increased? 4 times. So 4 raised to power Y, that's what you are getting mathematically, is equal to 4 raised to power 1. So Y is 1 exponential. Aisha? Children, this is okay? Because you are going to get plenty of such questions. So if you have any doubt, keep asking. This is how I determine my Y value. Can I determine X value? Yes. Pick up experiment 1 and 3. Why want to pick up 3? Because this will cancel. Y will cancel, right? So what is rate 3? Rate 3 is K times concentration of F2, which is 0.20 raised to power X, 0.010 raised to power Y. Now take the ratio of rate 3 with rate 1 and you will see rate 3 is this, rate 1 is this. How much is this? 2. Lisha has already done. And now you can see K and K cancelled. This number cancelled. So you're getting 2 over 1 raised to power X. So what is X? 1. So what's the order with respect to F2? With respect to F2, the order is also 1. So in experiment 1 and 3, when you double the concentration of F2, keeping ClO2 constant, the rate has increased exactly by the same amount, 2. So 2 raised to power X is 2. So it means X is 1. So there are 2 ways. First, mathematically you can do like this, the way I've shown. But you will see, you will not be using this mathematics much. You'll be doing like this, the way I was doing. This is doubled. This is doubled. Order is 1. This is doubled. This has become 4 times. Order is 2. This is doubled. This has become 8 times. Order is 3. Like this. So we'll do questions and things will be more clear to you. So now do you know the rate law, children? Rate equals to K times concentration of F2 raised to power 1, concentration of ClO2 raised to power 1, order 1, is called as first order kinetics. This is one order, this is one order. So I will say rate is first order with respect to F2. Rate is first order with respect to ClO2. Means you double this, rate doubles. You double this, rate doubles. So rate is equal to, that's the rate law. What's the overall rate law? Overall order, not the rate law. Overall order of the reaction, of this reaction, this one is 1 plus 1, 2. Add this value. What's the value of K? Value of K you can determine from any experiment. Pick up any experiment. And when you're calculating the value of K, please give the value of K with units. So what is K? I'm writing here. Yes, Afan, what is K? K is rate divided by concentration of F2, concentration of ClO2, right? Pick up any experiment, you will get the same value. So let's pick up experiment 1. Very good, Afan. Experiment 1. Rate is this 1.2 times 10 raised to minus 3. Plug in the units, molar per second. And F2, 0.10 raised to power 1. Order is 1, right? ClO2, 0.010 raised to power 1. Order is 1. This is molar. This is molar. What do you think? Molar, molar cancelled. And answer is 1.2 times 10 raised to power 0, 1. See, this is minus 3, this is minus 3 cancelled. So there is no 10 exponential. What are the units then? Units, children? See, molar, molar cancelled. What is left? Per molar per second. That's the unit for the second order kinetics. This reaction is second order. And these are the units. You're getting it, children? Any questions, Aditi? Ariba? Okay. No questions. Fine. Then I have questions. I'm going to show you different rate laws. So these are the questions, these type of questions. They will give you this data table and reaction, and they will ask you to find the rate law, to find the order, to find the units of K, to find the value of K from this experimental data. I have question. So rate laws you will see in different varieties. One is rate equal to K times concentration of A. I'm just taking general reaction A to B. This is the reaction. A times raised to power 0. What's the order here? What's the order? 0 order. Means, what does it mean? That you keep changing your A, you make it double, you make it triple, 10 times, nothing will happen to the rate. Rate will stay the same. So it is not concentration dependent. In the zero order kinetics, your rate is unaffected by the concentration of the reactant. Agreed? Okay. This is zero order. What are the units of K? Get the units of K here, children. Units of K. Rearrange. You know the units of rate? Molar per second. Now this is raised to power 0. You know the units of mole this. So molar raised to power 0. So what are the units of K? Anything raised to power 0 is 1. So units of K will be same because this rate law can be written as rate equals to K. What about rest of you? It is same, molar per second, right? Please practice it. Naisha, Aditi, Ariba, you're getting it? Now, I've done this for you. Now you're going to do this for me. Rate equal to K times concentration of A raised to power 1. What's the order of this reaction, children? What's the order? First order. What is the meaning of first order? Means if you double the concentration, rate doubles. You triple, rate becomes 3 times. You make it 4 times, rate will become 4 times. 1:1, right? Get the units of K. Units of K for the first order kinetics. Rearrange, plug in the units, cancel them, and see what is left. Waiting for the answer, Afan. Very good, Aditi, Anil, Afan is per second. Naisha, your answer? Third. Okay. Rate equals to K times concentration of A raised to power 2. This is second order kinetics. Second. 0, first, second. These are the only one which we are going to learn. Higher orders are rare. That you are going to learn in collision theory. Okay. So higher orders are rare. So these are the one which are more popular and most of the reaction they fall in this category. Okay. What are the units of K? No, Aditi. Aditi, do mathematics correctly. Rate is molar per second. Yes, Anil. Now it is right, Aditi. So it is per molar per second. Can you see? Molar second. It's a mathematical sequence. Zero order, molar per second. First order, molar cancelled, only per second. Second order, molar raised to power -1 per second. I said higher orders are not there, but let's say somebody asks you what's the rate law for the third order? K equals to concentration of A raised to power 3. What's the units of K? Don't you think it will be m-2 s-1? Isn't it? So that's why I'm asking you to look at the sequence and you can make a general formula for any order. For any order can be negative also, children. Order can be zero also. Zero you have seen. It can be negative, it can be in fractions also. And if somebody asks you to calculate the units of K, so I'm making your life simple. Units of K, sorry, units of K can be determined by this equation. M is molarity. You see everything has molarity and time. Molarity raised to power 1 minus n. Second minus 1. This is going to be same. You can see here per second, per second, per second, per second, because that's the one which is not cancelled out at all, right? So that per second is there. But this number is n. What is n? N is the order. Order 0, 1, 2, 3. Yes, Naisha. Very good, Naisha. So now let's see. N is the order. Now let's see if I say this is the rate law. Rate equals to K times concentration of A raised to power 3/2. So what's the order here? 3/2. So what's the unit of K? Yes, molarity 1 minus 3/2 per second, right? How much is this? M minus 1/2 per second. See? So using this equation, general equation, where n is the order, remember n is the order. Many children, they take it as moles or something. No, n represents moles also, but you can define n for anything. So right now I'm defining it as the order. That's the unit of K. Now questions. You're going to go very fast with the question because there are plenty of them. Yes, n is the overall order, Anil. Complete order. You're not going to take order with respect to every reactant. Complete order. Answer this question, children. The reaction is A and B are reacting to give you C. A plus B giving you C. So what's the rate law? Assume the rate law. The rate law will be rate equal to K times rate equal to K times concentration of A raised to power X, concentration of B raised to power Y. Question is, what is X and Y? And what's the overall order? Ready? Pick up experiment 1 and 2. What is cancelled? A. What is happening to B? 2 times. What is happening to rate? 2 times. So 2 raised to power Y is 2. So what is Y? 1. So order with respect to B is 1. Now get the value with for A. For A, what should cancelled out? B. For A, B must cancelled out. So pick up experiment 2 and 3. B cancelled out. See? So when you double the concentration of A, what is happening to the concentration of to the rate? When you double the concentration, what is happening to the rate? No change. It's 1. 2 raised to power X is 1. So it means X is 0. Only then it will become 1. X is 0. Anil, exponential mathematics, right? If somebody gives you 2 raised to power X equal to 1, then you can write it like this. 2 raised to power X is 2 raised to power 0. This is 1. So X is 0, right? So 0 order. What's the overall order of the reaction? 1. The way Lisa was saying. So Aditi, now what are the units of K? Order is 1. Do you remember what is the units of K for order 1? Per second. You have to memorize only 3 units. Molar per second for 0 order. Per second for first order. Per molar per second for second order. Right? So let's do the next question. Oh, we are right. See here. Do this one. So first you write down the rate law. Many children, they forget how to start. Start is, these are the reactants, right? So what's the rate law? K times concentration of NO raised to power X. I'm repeating this step again and again because this is something that can confuse you in the paper. Always do this, always, whether they are asking or not asking. Look at the reactants, write down the rate law in terms of order X and Y. Done? What's the order with respect to Cl2? So I have to pick up experiment where NO is NO is changing, not changing, sorry. NO is not changing. Where? 1 and 2? Check, check. This is double 2 raised to power x. How much time this has increased or decreased? Increased. How many times? Doubled. So 2 raised to power 1, right? So what is x? X, no, it's what? Y, sorry. This is Cl2, Y. So first, do this one. Can you tell me which two experiments you are going to pick up for this, Afan? To know NO, which two experiments? Like for Cl2, I picked up the experiment in which NO is not changing. Which two experiments we need to pick up for NO? Afan, your answers are not coming at all. Why? Why, Afan? Can you give me the reason why you want to pick up 2 and 3? What's the reason? Yes, they cancelled out. Very good, Afan. And this you can write down twice. How much time is this? Use your calculator, children. How much time is this? No, because this is -6, this is -5. I think this is 4 times. Can you check? Take the ratio 1.14 times 10 is to -5. Use your calculator. Divided by this number. Is it 4 times? Naisha, Aditi, Ariba? So that is 4 nearly. No, 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 Aditi. You do it like this. 1.14 times 10 raised to power -5 divided by 2.86 times 10 raised to power -6. Put parenthesis for the denominator. If you don't put parenthesis in the denominator, your answer will be wrong. Now check how much you are getting. You must be getting 3.98, which can be taken as 4. So this has increased 2 times, 2 raised to power x. How much is this? 2 raised to power y. Oh, sorry, 2 raised to power 2. Sorry, 2 raised to power 2. This number is 2 raised to power 2. So what is x? 2. So keep doing these calculations with me. You will come to know your error in thinking. If you do work with me, you show your answers, only then I can correct you, children. I'm very happy with children are asking questions and doing work with me because that's how the learning should go. So 2 plus 1 is 3. Get the units of K. Yeah, Anil is writing units of K. Naisha asked a big question in between. Okay, she's saying that if the rate law, the order is negative, what does it mean? Anyone? Let's say rate equals to K times concentration of A raised to power -1. What is the meaning? The meaning is when the concentration of A is doubled, rate will become half. Rate will decrease to half. If the concentration of A is 2 times, if you increase it, rate will become half. That's the meaning. Rate will decrease. Negative order means with the increase in concentration of the reactant, the rate will decrease. Second order in half-life means that's a different thing, Lisa. In that case, we are saying that as you increase the concentration of the reactant. No, 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 no. I'm asking, answering question asked by Naisha. What you are talking about? You started talking about half-life. You know, children, schools are ahead. Many children have already done it. Okay. So what she is saying, definitely it will come. She's talking about half-life. And you will see, we'll talk about the half-life of zero order, second order, but that's a different concept. We'll do it after finishing these questions. Ready for more questions? So this is the rate law points, important points. First, remember these points. Rate laws, you need experimental data. You know, I was showing you a table and then we were working with the table and getting the rate law. It is determined experimentally. You cannot look at the equation and say the rate law is this. I was like, for example, here, what was the rate law? We worked with this equation. You remember the rate law for this? K times concentration of F2 raised to power 1, ClO2 raised to power 1. Can you see? This coefficient and this one are not matching, right? This coefficient and this one are not matching. This, so it means orders, these are orders. Orders are not the coefficients of the balanced equation. No, they are not. You have to determine these orders experimentally. So please remember this. Rate law is determined experimentally. Rate law is always in terms of the reactants, never in products. We never talk about products here. We just take the reactants. Third, the order of the reaction is determined experimentally, not by looking at the coefficients of the balanced equation. All the points are clear? These can be multiple choice questions. The points. Okay. This is what I was explaining you. Ready for this question, children? Do it fast. So first, look at the equation and write down the rate law. Rate law with x and y order. So Afan, what is the rate law for this equation? Rate equals to K times concentration of S2O8 2 minus raised to power x. That x is not 1. Times concentration of I minus raised to power y. Children, done? Now look at this table, get the value of x and y. Here, this is the experiment. Naisha, I'm answering your question. This is the experimental data. So you perform the experiment. This is how you're going to determine. Right now, I asked the same question, what you are asking. Till now, we were doing this only. Look at the experimental data, determine the order x and y. Till now, we were doing this question only, Naisha. So what's the order with respect to S2O82 minus? Which two experiments you are going to take? For this, which two experiments you are going to take? 2 and 3. Take these two because this is constant, cancelled. How many times this has increased? How many times this has increased? What's the order? This is 2 raised to power x, this is 2 raised to power 1. So x is 1. Now to determine y, which two experiments should I pick up? Everybody is getting it? Very simple question. Don't lose marks in this. So this cancelled. How many times? This has decreased by half, decreased. How many times rate has decreased? By half. So 1 by 2 raised to power y is 1 by 2. So what is y here? Clear, children? So Naisha, I think your question is answered. This is the experimental data. And from this experimental data, we are calculating the orders. And from the equation, we are assuming the rate law in terms of x and y. Now then we are working for x and y. But this question has one more part. Determine the rate law. Done. Calculate the rate constant. Yes, who is going to help me? Rate constant. Pick up any experiment, any, and plug in the values. Like, which one you want to pick up? Let's pick up third. You will get same rate law, K value for all of them because reaction is same. Temperature is same. So all the three experiments are done at the same temperature. So the value of K is same. So you can pick up any and plug in the values like this one. 2.2 times 10 raised to power minus 4 is K. Concentration of S2O8 is 0.16 raised to power 1, 0.017 raised to power 1. Get the value of K. Give the units. When you are writing the value of K, give the value of K with units. Here, all of you. Please do it. What is D? Naisha, what are you typing? Children, you are giving me the answer? Aditi is saying 0.081. Yeah. Aditi and Anil are near, correct. Okay. How many sig fig, Aditi? How many sig fig you should have? 2. But why? This number has only 1. Are we using? Oh, we are doing this. Yeah, 2. So Aditi is right, Anil. So answer is 8.1 times 10 raised to power minus 2 molar per molar per second. Second order, 1 plus 1, 2. Liza, we are okay with this? Afan, no answers? Ariba, Afan, you're not answering at all. No answers? Okay. Ariba said she answered. Okay, good. Where, Ariba? Oh, way back. Not with the K, right? Keep interacting continuously. And try to put numbers in scientific notations. Okay. Okay, good. No problem. So they have picked up which experiment? Which experiment they have picked up? 2.2, 10 is to minus 4. This one, experiment 1. What's the answer? See? Now they are taking only one sig fig because this 0.08 has only one. So answer is in one sig fig. You can see that your answer and their answer is the same. The reason is K value is constant. K value will change only by changing the temperature. For a reaction, K values are constant. That's why it is called as rate constant. Ready for another question? Okay, let's do it. First one on the top. Write down the rate law. Assume the rate law, children. Type it here in the chat. Rate law. Rate equals to, yeah, type it. You will take the sig fig of your calculation part. Rate equals to, assume the rate law from here. When you're going to plug in the values, you will take sig fig from there. Minimum sig fig. Rate equals to, yes, children. Assume the rate law only in terms of the reactant. Raised to power some coefficient x. I'm not going to write it till that time. Okay, Aditi is right. Rate equals to K times. So children, if you don't type, don't answer, you will forget this. If you forget this, you won't be able to solve the question. Right? Okay. Now, look at these values. Pick up any two values, any two values. There's only one reactant, experiment 1, 2, 3, 4. Let's pick up experiment 1 and experiment 3. How many times N2O5 has increased? Check. Take the ratio. 0.275. Lisa, you're doing it? 0.0750 is nearly 3.3 times. Nearly 3.3. How many times this rate has increased? Check. 3.26, 0.90 multiplied by 10. Same, 3.6, nearly same. Nearly same because this is experimental data. In experimental data, there can be errors. So here you can say they are nearly same. So what's the value of X? Yes, Lisa. What is 1? Determine the rate as this. Write the rate law. Calculate the value of K. So the rate law is K times concentration of N2O5 raised to power 1. Now you can pick up any experimental value. Any experiment. First experiment, let's say. Plug in the values. What is the unit? Yeah, that will do. I'm just doing this part now. This I will do. So K is rate. How much is the rate for experiment 1? 0.0750 divided by 8.90 times 10 raised to the minus 4 units per second. But determine the rate law as this. Determine the rate as this. That's the average. You can pick up this as initial, this as final. So minus, keep this minus. 0.410 minus 0.0750 divided by total time taken. Time, this is final, this is initial. So 4.85, 10 raised to a minus 3 minus 8.90, 10 raised to power minus 4. Solve it. Yes. But generally when nothing is mentioned, then pick up first value and the last value. Okay. So is this question done? In fact, when you write down this rate law here like this rate is this only. This is rate. So in many books, they write it like this. This is the rate is K times concentration of N2O5 raised to power 1. They write it like this also. So this is the normal average rate and this is the rate law. Ready for one more? This one, children. Can we do it fast? Rate is written here in terms of this Cl2. But what's the rate law? First thing, rate law. K times, yes please, type it here. Naisha, type the rate law. The assumed one, looking at the equation in terms of x and y. NO raised to power x, Cl2 raised to power y. That's the rate law. You have to write the rate law from the equation, from the reactants of the equation. I can express average rate in terms of Cl2, the way they are showing, or I can express average rate in terms of NO. So it doesn't matter, right? But the rate law is this. These are average rates with respect to Cl2. Average rate of Cl2 and average rate of NO will not be the same. The rate of NO is twice than that of the Cl2. So all these things we have done. But when they say rate law, like this, get the value of X and Y, children, the way I told you. NO, experiment 1 and 2 and 3. NO cancelled. Cl2 doubled, right? And this initial rate doubled. So what is X? Oh, sorry, what is Y? This Y, Cl2. Y is 1. Now pick up experiment 2 and 3. This cancelled. This is doubled. How many times this has increased? 4 times. So 2 raised to power x is 4. That is 2 raised to power 2. So order is 2. Very good, Naisha. Very good. Perfect. So what's the value of rate constant? You can do it. So all these are now mathematical questions. Okay, children. So I think we have done the rate laws. This is the last question which is left. And I don't think we have time. Do we have time? Yes, we can do it very fast, right? Write down the rate law. Rate equals to, yes, Naisha, K times concentration of I minus raised to power X. Concentration of OCl minus raised to power Y. We call it as assumed rate law. Looking at the equation, assumed rate law. Now, experiment 1, 2, 3, 4. If I take experiment 1 and 2, what is cancelled upon? How many times this I minus has decreased? 2 times, 1 by 2. How many times the rate has decreased? 1 by 2, isn't it? So what's the order with respect to I minus? This X is 1. Afan, you're not doing? You've understood why I picked up 1 and 2. But what should I do for Y? Is there any value of I minus which is constant in any of the experiment? Is the I minus constant? No. So don't worry. You pick up an experiment in which OCl minus is changing, like let's say 2 and 3. And then plug in the values. What is rate? This is rate 3. This is rate 2. So rate 3, rate 2 over rate 3. How much is that? Take the ratio. 3.95 times 10 raised to minus 2. Anyone doing calculations or ready to run out of the class? What's the answer here? Yes, children? It's 39.5 divided by, it's nearly 4. Nearly 4. I'm not using calculator. But then you plug in rate 2, which is equal to, this 4 is equal to 0. K times 0.060 raised to power 1, 0.18 raised to power y, divided by K 0.030 raised to power 1, 0.090 raised to power y. K cancelled. This number is 2. So 4 is 2. And this number is also 2. 2 raised to power y. So 2 raised to power y is 4 divided by 2. This is 2. So y is 1. Right, children? So we are done with the rate laws. Average rates, instantaneous rates, and rate laws. Next class will be on integrated rate laws and collision theory. So join at the right time. See you then. Bye bye. If you have any questions, you can stay.